In this video, we will demonstrate how to use the digital compound microscope. First, we will identify its parts and state their functions. Then we will demo how to prepare a wet mount of an Elodea plant. Here are the parts of the microscope. The ocular or the eyepiece are the lens that you can see through and magnify object 10 times. The head holds the ocular. The arm supports the head and is used for carrying the microscope. The base is also used for carrying the microscope. The prism slider bar has 3 positions. All the way in delivers 100% light to the ocular. Midpoint delivers 100% light to the computer, and all the way out splits the light 50-50 between the ocular and the computer. The nose piece is the revolving part that attaches the objective lens. The objective lens, we have 4x for scanning, 10x for low magnification, and up to 100x for high magnification. The stage is where you put the slides, and we use the slide holder to position the slide. And then we use the mechanical stage knobs to move the slide towards the left, the right, or forward and backwards. The rheostat regulates the voltage and light intensity. And the iris diaphragm is used to regulate the amount of light going through the sample. The coarse adjustment knob is used to move the stage up and down to bring the specimen into focus. And the fine adjustment knob is used for final fine focusing. We will now demonstrate how to prepare 2 different wet mounts. The first sample we're using is a sample of freshwater Elodea plant. So we will start by getting a slide and then picking a young leaf of Elodea. We will place it on the slide. And then we're gonna wet the sample with just a drop of water. And now we cover it with a cover slip. Now our sample is ready to be viewed under the digital microscope. So after putting the slide in the digital microscope, we go to the icon and then we go to File, New, and we click OK on live video. We start by viewing our slide at a 4x magnification, and then we move higher to 10x magnification, and we adjust the coarse and the fine adjustment for better focus. Then we go to the highest objective magnification of 40x. We again adjust the coarse and the fine adjustment for a more focused view of the slide. We have to then go to Measure, Calibration, and move the magnification from 4x to 40x so the software could recognize the magnification that we're on. As the leaf warms up, we can see the green chloroplast move. This circular flow is called cytoplasmic streaming that ends up distributing the materials within the cells. Now I'm going to show you how to prepare a second wet mount using onion epidermis. We will take a clean slide and then we place a drop of water on it. And then we're going to cut an onion epidermis and place it on the slide. And then we're going to stain the onion epidermis with 2 drops of Lugol's iodine. We'll cover the slide with a cover slip and then we'll wipe any excess water using a Kim wipe. Now the slide of the onion epidermis is ready to be viewed under the digital microscope. So now we placed our slide of onion epidermis at the digital microscope and we are starting at 4x scanning. Then we will move to 10x magnification. As you can see on the slide, the cell walls and the nuclei of the onion epidermis were stained by the Lugol's iodine. One of the advantages of the digital microscope is that we could measure the length and the width of the cell, which would enable us to calculate the area of the cell of the onion epidermis. To measure the length and the width of the cell, we have to reset the software on the magnification we are using. So first we go to Measure, Calibrations, and in this case we're using a 10x magnification. And then we go to Measure again, Line, and then we draw a line across from the cell. And this way we will be able to measure the length and the width of the cell. And by getting these measurements, we could calculate the area of the cell.